Hello, we will now solve exercise 3 in unit 3, motion in 2 dimensions. So in exercise 3, a skier leaves the ramp of a ski jump with a velocity of 10 meters per second, 15 degrees above the horizontal as in the figure below. The slope is inclined at 50 degrees and air resistance is negligible. So we have a skier who's leaving the ramp of a ski jump. هيدي هي ski jump يعني النط القفز. So في عنا a skier, the person who is playing ski, and this is the ramp of the ski jump. ramp هون قصدن من المنحدر تبع السكي jump. So a skier leaves the ramp of a ski jump with a velocity of 10 meters per second. This is the initial velocity. مثل ما نكون شايفين, this is the initial velocity 10 meters per second in this direction, 15 degrees above the horizontal. This is 15 degrees above the horizontal. The slope is inclined at 50 degrees. قصدا عن هيدا الانجل, هيدا slope. The slope is inclined at 50 degrees and air resistance is negligible. Find A, the distance from the ramp to where the jumper lands. So this is the skier. He will jump like this. He will follow a projectile path. He's making a projectile motion. بده ينزل لتحت بالأخير. So في عنا projectile motion. مطلوب مني طلع distance from the ramp to where the jumper lands. Where the jumper lands يعني وين الجمبر صار على الأرض. lands يعني بيهبط على الأرض, on the land هي الأرض. So المفروض طلع distance يعني من هون لنفترض هو نط هيك. هلا هون طولناها. So نط وصل مثلا لهون. So من هون لهون distance. We want to calculate the distance from the ramp. هون ramp. The distance from the ramp to where the jumper lands. لنفترض إنه let's suppose that the skier lands here. So we want to calculate the distance from the ramp to here, to where the jumper lands. أول شي مطلوب مني يطلع distance D. Okay, so first of all we write the given information. We have, first of all, the initial velocity is 10 meters per second. The initial angle, let's call this angle theta 1, it's 15 degrees, and theta 2 is 50 degrees, and we want to calculate the distance D. So we want to define the initial time and the initial position. So this is the initial position. We define it. So we define t equals 0, x equals 0, and y equals 0 at the position where the jumper leaves the ramp. Where the jumper leaves the ramp يعني بالposition محل ما هيدا الشخص ترك الرامب هون. يعني محل ما بلش ينط. And we know that this is a projectile motion. As in the previous exercises, we need to define the initial position and the final position. The initial position is defined by the initial time ti 0 second. The position vector is defined by xi 0 and yi equals 0. من هون بلشنا الأوريجين إذا بدكن. And vi. Okay, what is vi in this case? Vi, هيدا هو ال vi كvector. Okay, it has two components. It has a component along x and a component along y. مثل ما قلنا إذا بنعمل projection للinitial velocity on the x-axis, we will obtain vxi اللي هي هون. And if we make a projection of vi onto the y-axis, we will obtain vyi. By similarity, like in the previous exercises, we will obtain vxi which is equal to VI cosine this angle 15 degree. So VI cosine theta I, VI is equal to 10 and theta I هيدي this is 15. So Vxi is equal to 9.7 meters per second. Vyi is equal to Vi sine theta I, which is equal to 2.6 meters per second. And Vi, which is the square root of Vxi squared plus Vyi squared. إذا بنعمل هالcalculation بنحصل على Vi 10 meters per second. Yes, مظبوط. So this is a type of checking our answer. لأنه لو ما طلع ال VI 10 meters per second مثل ما كانوا عاطينا إياها given information هون معناتها في شي غلط. So هون مشينا فيهم بسرعة because this is a repetition of the previous exercises. And we will define the final position as the position where the jumper lands. It's defined by TF, which is unknown. ما بعرف بأي instant of time بعد قديش بيهبط أو the jumper lands. We don't know what is TF. And also we don't know what is XF and what is YF. Concerning the final velocity, VF, again it's defined by Vxf and Vyf. Vyf for the moment is unknown. Vxf we know it لأنه بنعرف that in the projectile motion Vxf is equal to Vxi because we have a constant velocity model along the x-axis. عطول ال Vxf قد ال Vxi بالprojectile motion, which is equal to 9.7 meters per second. And the acceleration بدي ارجع حتى Ax is equal to 0 and Ay is equal to minus g because the acceleration is equal to g. Okay. So we have a constant velocity along x and a constant acceleration along y. We are repeating the same things, the same methodology again and again. Okay, so we want to, in question A, we want to calculate the distance d from the ramp to where the jumper lands. So we need to calculate this distance d. So المفروض إني أعرف أول شي ال XF وال YF normally. So we want to determine XF and YF لحتى أقدر أطلع ال D. So this is the distance D. Okay, this is the distance D. And this is XF and this is YF. Okay. So since the jumper has a constant velocity along x, we apply the constant velocity model along x to determine XF. We are repeating the same equations. This is the equation corresponding to the constant velocity model. XF is equal to xi plus Vx times delta t. Xi, what is xi? We need to go back to the previous slide. Xi بحطها 1. xi بحطها 0. xi is equal to 0. So بحط xi 0 plus Vx delta t. Vx شو هي ال Vx؟ Vx برجع لهون ال Vx Vxi ولا Vxf نفس الشي لأنه because they are the same. So we substitute Vx with 9.7. So حطينا هون 9.7 times delta t. Delta t is equal to Tf minus Ti. So Tf ما بعرفها minus Ti. Ti هي 0. So I keep delta t equal to Tf. Okay. And so I obtain XF equal to 9.7 TF. Very good. Now along the y-axis عطول I need to separate my motion into two motions. The motion along x and the motion along y. And for the motion along x we have a constant velocity model, whereas on the motion along y we have a constant acceleration model. So we have, since we have a constant acceleration model along the y-axis, we can use this equation. Yf is equal to yi plus vyi times t plus the half of ayt squared. again yi is equal to 0. vyi خلينا ارجع اشوف شو هي ال vyi هي 2.6 meters per second. شفتوا قديش مهمة هالسلايد because we will go back to this slide wherever we want to make a calculation. So vyi is equal to 2.6 meters per second. vyi 2.6 on t. T, what is T? T يعني delta T, delta T, TF minus TI, which is equal to TF. So I substitute T with TF plus the half of AY. AY هي minus 9.8 meters per second squared مثل ما بنعرفها times TF squared. So I obtain my second equation, YF equal minus 4.9 TF squared plus 2.6 TF. Okay, again we obtain two equations with three unknowns. Two equations with three unknowns. يلي هن شو هن unknowns xf, yf and tf. How can I solve such a system? In fact, I cannot solve such a system. I need a third equation. I need to write a third equation بقلبها نفس ال unknowns. So I need to find another equation. So here we have two equations with three unknowns xf, yf, and tf. They are not sufficient to determine to calculate the three unknowns. So I need to add another equation. شو هي another equation? So خلينا نحط ال xf مثل يلي طلعناها على جنب وال yf يلي طلعناها على جنب. And from the figure, what can we calculate? We know that we can find a relationship between D, XF, and this angle 50. And also we can find another relationship between YF, D, and 50 using sine and cosine. So if we want to find XF in fact is equal to D cosine 50. كيف طلعناها؟ اعملوا cosine 50 على جنب. شو بتساوي cosine 50? This is equal to the adjacent side over the hypotenuse. The adjacent side is xf over d. So cosine 50 is equal to xf over d. معناتها xf is equal to d cosine 50. And also yf. كيف بدي طلع ال yf؟ بدي شوف الساين. ساين لل 50. Sine of 50 شو بتساوي؟ It's the opposite side over the hypotenuse. So the opposite sides من هون لهون distance. عم نشوف distance هي okay YF هي it is a negative value. لازم حط لها minus لحتى تصير positive لأنه sin 50 بدي أشوف distance اللي the distance من هون لهون. The distance من هون لهون لازم تكون positive. And YF has a negative value because the y direction is up. بينما ال YF هي لتحت. يعني ال YF هي أساسا a negative value. So لازم أحط لها minus y لحتى تطلع عندي لحتى أطلع هيدي distance من هون لهون. So sin 50 is equal to minus YF over D. معناتها YF is equal to minus D sin 50. We are in fact repeating the same methodology as in exercise 2. That's why I'm a little bit quick. So here we found the equation, this equation and this equation, equation 1 and 2. Now, as I told you, I need to find a third equation. منين بدي طلع هالثيرد equation؟ هلا هون أنا بشوف هون هيدا system of equations فيهم D. so أنا I need to get rid of D. I need to eliminate D to find a relationship between XF and YF. اوكي، هو للحقيقة نحن بحاجة ل third equation بقلبها XF YF and TF بالكتير، أو إذا كانت relationship between XF and YF كمان منيحة. المهم بالثيرد equation ما ينضاف عندي unknowns جدد لحتى أقدر حل system of equation. So the best or one of the best suggestion is to eliminate D by dividing 2 by 1. If we divide 2 by 1, we will eliminate D. So let's look at 2 over 1. It gives, so 2 over 1 gives YF over XF, which is equal to minus d sine 50 over d cosine 50. So d and d cancel each other. We obtain sine over cosine, this is tangent 50, and we have the minus sign, we don't forget it, equal yf over xf. شفتوا هيدي هي ال third equation اللي فينا نحطها هون، فينا نستعملها. دغري أنا حليت ال equation، صار فينا we can use this relationship to solve the system of equation. كأنه صار عندي أنا system of 3 equations with 3 unknowns. هيدي ال equation، هيدي التانية وهيدي التالتة. We have 3 equations with 3 unknowns xf, yf and tf, so we can solve it mathematically to deduce xf, yf and tf. So minus tangent 50 is equal to yf over xf. هلا إذا بحط ال yf بقيمتها هون as a function of tf وال xf بقيمتها as a function of tf also. So we will obtain minus 4.9 tf squared plus 2.6 tf over 9.7 tf. You will notice that we can cancel. إذا بتطلعوا مثلا بتعملوا factorization تطلع tf لبرا هون وهيدي بتطلع لبرا، بنعمل tf من فوق و tf من تحت، أو simply بشيل tf هون، هي بتروح مع هي و tf هيدي بتروح مع هيدي. So we will obtain minus 0.51 tf plus 0.27. منين اجت ال minus 0.51؟ هي إذا بتعملوا minus 4.9 over 9.7 you will obtain this value. And if you divide 2.6 over 9.7 you'll obtain 0.27. So look at this result. We have minus tangent 50 equal minus 0.51 tf plus 0.27. The only unknown in this equation is tf, so we can deduce tf. tf is equal to 2.87 seconds. Again ما تنسوا هون tangent 50. You have to pay attention while using the calculator. You have to use the appropriate unit of angles. لازم تعملوا الunit تحطوها بالdegrees not in radians. So tf is equal to 2.87 seconds. We substitute this tf with its value in xf, so we can obtain xf and yf. xf is equal to 27.8 meters and yf is equal to minus 32.9 meters. Let's check our answer if it's logical or no. xf is positive. xf is positive, yes، لأنه هو الجامبر رح ينط رح يوصل لهون. where the x is positive, yes. and ال yf شو المفروض تطلع؟ ال yf هي عندها value negative لأنه هي لتحت، لأنه in fact الجامبر عم ينزل لتحت والpositive positive direction is chosen upward بينما هو عم ينزل. so yf should be negative. Yes, it is correct. So question A is solved. In question A we are asked to find the distance. ما خلصنا. We are asked to find the distance D. We know that xf is equal to D cosine 50 يلي هي هون. بحط ال xf بقيمتها بطلع ال distance D. Okay, so it's 43.2 meters. Or in fact, we have another solution. Simply in this right triangle, we have d squared is equal to xf squared plus yf squared using Pythagoras théorème de Pythagore. حطوها بتطلع دي equal x the square root of xf squared plus yf squared, so it's equal to 43.2 meters. هيدي طريقة تانية لنطلع d because we already know xf and we know yf. We can substitute them with their values and we obtain d. هيدي طريقة، والطريقة التانية هي دي. Perfect. We have our both methods led to the same answer. يعني على الأغلب إنه يكون جوابنا صحيح، وهو أكيد صح هون. So I can go back to our previous slide where we wrote the initial position and the final position. هلا صار فيني أحط بدال TF اللي هي طلعناها 2.87 seconds. We update in fact the initial position and the final position. بنحط محل TF كان عنا علامة استفهام، بنحط 2.87. XF we write its value 27.8 والYF بحطها بقيمتها. اوكي so بعمل update لل initial and final position. Now concerning question B. In question B we have find the velocity components just before the landing. Just before the landing يعني قبل قبل بثانية من ما يوصل الجامبر على الأرض. يعني عم يسألونا شو هن ال VXF وال VYF. Find the velocity components. Components يعني les composantes. Les composantes de la vitesse. يعني VXF and VYF. In question B, we are asked to find VXF and VYF. It's simple. We already know what's VXF. VXF is equal to VXI because we have a constant velocity model along the x-axis. And we need to find VYF. How to find VYF? VYF أول شي فكر كيف يطلع ال VYF. VYF هي على ال y-axis. We have something special at the y-axis. We have in fact a constant acceleration model along y. So I need to use one of the four equations corresponding to the constant acceleration model to find VYF. I used in fact this equation لأنه في عندي شو هن ال only unknowns in this equation. VYI معيها AY معيها والTF طلعناها, so we can deduce simply VYF. VYI بشوفها شو بتساوي ال VYI هي 2.6 بحطها بقيمتها. AY is equal to minus 9.8 time T. شو هو time T 2.87. شفتوا قديش مهم اني اعمل update للفاينل position لحتى احط زيد الاشياء اللي ما كنت بعرفها صرت بعرفها. Okay, and we obtain VYF. It's minus 25.5 meters per second. Is it logical to have a minus here? تعالوا نشوف. بالنسبة لل VY is it logical to have a negative value? ال VY هي نازلة لتحت. So the jumper will jump like this وبده يوصل لتحت. على طول ال velocity هي the velocity vector is tangent to the path والpath هو هيك لنفترض هو هون. So ال velocity هي لتحت راح تكون لتحت to the right كمان. So it's directed down راح تكون ال VY negative. إذا عملتوا calculation طلعت معكم ال VYF positive معناتها there is something wrong for sure. So you need to recheck your answer and review to find the mistake. Okay, so this exercise was a typical exercise. This is kind of repetition of exercise 2. It's given just for practice.